How's it going? And welcome back to building a deep learning framework from scratch. Today we're going to walk through a couple of toy examples and demonstrate how easily it is to transition from one problem to the next. Just the only thing you need to have defined are your data loading functions and then also your models. So for the two toy examples, the first one I'm going to do is this Titanic machine learning from disaster. This is just a knowledge data set and knowledge problem on Kaggle. It's a binary classification problem where we're going to try to decide or predict whether or not someone would have survived the Titanic crash based on some features and some attributes about the person. And then the second one we're going to do is a image classification task, which is just this simple, very small 5 celebrity faces data set where we give them some training data of particular celebrities and we try to build a model that can predict from another test data set who is who. So let's go ahead and get started. So if you've been following along, I've kind of defined, we've gone through to find the data loading functions, the models, and then the training script. So one thing is when it comes to different problems, you're going to have to adjust the models and then you're also going to have to adjust the data. For the most part, the training workflow should work for all of your different projects. There is opportunity to add in increased functionality, different optimization algorithms, or different types of callbacks. It's very easy to just kind of adjust what you see fit. But for this example, so one of the things I forgot to do in the last example was add in an actual input layer on our sequential DNN. So I went ahead and added that in. So now I set the shape in the config file. And then also, since this is going to be used for a classification problem instead of a regression problem, we change the activation function to sigmoid. Sigmoid because it's binary. If it were to be multi-class, we would change it to a softmax. But so for this particular example, we'll be doing sigmoid. So go ahead and make those changes. And then to kind of highlight the data functions, so I kind of have some of my helper functions. One hot encode, enumerate and encode, they also kind of go along with one hot encode. I have my transformation function. So these are the transformations I'm going to want to apply to the training and validation data sets. And then I have my load point, right? So down here, I load in the CSV for training or validation, and then I apply the transform function to the data frame. And then once we get to our image classification problem, then we're going to be using this pre-process function. So basically we're going to read in our image, resize it to the shape we're setting in our config file, one hot encode it to the number of classes based again on our config file, and then return the image and the target in the form of tensors so that they can, and also in the form of floating tensors so that they can be then sent to our models. So then you come down, we have our dataset functions. So these are actually our TensorFlow dataset functions where we pull in the tensor slices and then return a dataset. This one's for the point, and then this one is for the image. So kind of the big difference here is that here we're actually mapping the pre-process function to our inputs for the image, and then for the point we aren't doing that. We're doing our transformations previously to the actual data frame. So okay, so moving on. So we're going to go ahead and look at our config file. So we're going to need some of our base functionality and then also any other parameters that are going to be needed based on your functions you write. So we're going to go ahead and define those here. We want to use our DNN. We want to use load point, our TF point. We want to pass, this is our transformation function. And then here is the CSV of the training data, CSV of the validation data. We have 44 input features, so that's going to be the shape. And then for now, these are the different dense layer sizes we want and the number of layers we want. We want to run batches of 16, and then we want to do 50 epochs. Optimizer atom, learning rate 1e to the -2. And then again, because it is a classification problem, we're going to be doing binary cross entropy, and then our metric is going to be accuracy. So, and then our output file is going to go into our output folder. So that's the rundown for that problem. And then for our config file for our second problem, we want to again load the different models. We want our CNN with our config. We want to use load image, TF image. This is our training CSV, our validation CSV. This is the shape of the input images that we're going to be using. The number of filters for our convolutional blocks is 64. We want to apply batch norm. Here is our list of dropouts. We have 5 target classes, batch of 16, 50 epochs. Again, then optimizer is atom. And then we have 1e to the -2. And then again, binary cross entropy and accuracy. So to show how you go and run these and how you can transition quickly between the two, we're going to go ahead and open up our terminal. I'm going to go to this folder, and then we're going to activate our Conda environment. So now that we have our Conda environment activated, I'm going to go ahead and run Python train.py, and then if you remember, the command line argument that we're going to be passing to that is which config file we want to run. So go ahead and run the first one. This is going to be the Titanic problem, the binary classification problem. We're going to go ahead and run it, and now you can see our model spits out the summary of our model, and then now it's training. So now we can kind of watch as the model trains and runs through the 50 epochs. This isn't fully optimized. This is, I've did very minimal feature engineering and data analysis prior to running these. These are just to give an example of how to transition from one project to the next. If I were to actually try to like do a little more in-depth work on these, there would be a lot more pre-processing steps, which we'll actually dive more into as we go into more problems. Okay, so there's the first model. So we went ahead and we ran our model. We can go ahead and look. I've done this in the past, but it spit out our DNN for the day and saves our model output. So the next one we want to run is we want to run the same thing, but we want to go ahead and run the second config. So go ahead and let the data sets load. There again, we see a summary of our model that's being trained, the number of total parameters, and then we go ahead and training the model. So since this is an image classification task and I'm only running it on CPUs, it's really slow. I'm not going to actually allow it to run to completion here. Just again, we see that it is running and it is working for the problem. So I'm going to go ahead and cancel that. And what we're going to do is go ahead and take a look at some of the outputs. So these are some past outputs as I was kind of iterating through and working on this project. But what's really nice is some of the callbacks I've set up is they spit out the exact config, and then it also adds to the best fit model. It's happened on epoch 1. The accuracy for that model was 83%. This is the loss, and then these are the validation scores. So kind of tracks, through the training of the model, which checkpoint of that model is going to be the best. Here is a CSV of the training and validation loss curves and the metric curves. So you can go ahead and use this for plotting and some post model training analysis to determine, if the models are overfitting, underfitting, or where that's occurring, and also helps you do some hyperparameter tuning. And then the actual models are then saved in these H5 files, and they're all time stamped, and we can go ahead and see which one was trained when, and we can go ahead and refer back to our outputs as to which model we might want to load in for some post process or some using the model on some kind of downstream task. So that's kind of the basics of it. As I go forward and I start working on some actual problems, once we move beyond just building up this framework, I'm going to be implementing my version of this or tweaking things. I might not necessarily cover everything unless, it's kind of asked for or wanted. But this is just kind of a general setup, and my general setup, at least how I code and structure my entire workflows so that I can transition and iterate on different problems quickly and efficiently. So I hope you enjoyed. I hope you got something meaningful out of it, and I'll see you next time.